I want to talk a little bit about, this is going to be an introductory level talk to AI and artificial intelligence, kind of give you an idea of the scope of what we're dealing with. My remote doesn't work, so I'm going to use the old-fashioned clicker. So, why would you want to work in AI or artificial intelligence? Well, this is just recently from the New York Times. I think this is maybe even a week or two ago. And it talked about AI researchers are making more than $1 million a year in salary, and this is at even nonprofits. This isn't talking about private corporations. So Ilya, and I can't pronounce his last name, so if he's watching, I apologize. It's Sutskever. Works at OpenAI, which is a nonprofit which is dedicated to keeping artificial intelligence open to people around the world, so they don't privatize their techniques. And he made $1.9 million. Now, he does some incredible work on what are called GANs, Generative Adversarial Networks, which we'll talk about a little bit, RNNs, which are starting to fall out of fashion, interestingly enough. And right now, there's estimate, from this article, there's only about 22,000 people in the entire world who know what the heck is going on. Which is, if you think about the demand and what is required and what's necessary, there is a major critical shortage worldwide of people who understand AI. So if you want to make a ton of money, and you want to make a ton of money over the next 10 to 20 years, it's not a bad field to be interested in. Now, of course, not everybody's interested in money, and that's not necessarily what motivates them, so maybe you want to save the world. Okay? There's a lot of people who want to do that as well. And so there's these new corporations that are out. They're called B corporations, which are for social good. And so you can start a company and not be interested as much in profit, and still work for social good. And it's actually it's an interesting style that's being set up, and a lot of people are using it today. And this is tough to see, but this is the AI for Good Global Summit. So the United Nations is running a lot of AI stuff right now in 22 different categories to try to make the world a better place. And these are things like, how do we get people better access to water, better housing? How do we grow better agriculture? All kinds of things. There's 22 different areas that they're working on. And so if you want to do a lot of good, that's another area that you can work on AI as well. And of course, if you just want to take down Skynet, which is something that I'm interested in, I'm more of a cause-based person. You'll notice a few of the logos that are on there of people who are going to accidentally blow up the world. If you listen to Elon Musk, and they may, I'm just putting that out there, that's something else that you could do as well. If you don't know what Skynet is, you have to watch Terminator. So what are we talking about here? What is AI and artificial intelligence? This is a large topic, okay? So let's talk about some of these things. So up here, this is data and how you take your data and do things with it. So like Amazon, when you shop at something on Amazon, and then it says, hey, these things are related to what you just bought. Or interested, ads on maybe Instagram or Snapchat or Facebook or wherever you are, those are AI algorithms. And it's called retargeted marketing. Or you want to do financial predictions. This is a lot of like sorting data, big mountains of data. Okay? Now, here's if you want to work on machines. So this is the Waymo car. These are a bunch of engineers who left Google and started up this self-driving cars. Driving fatalities are a major problem in the United States of America. And so this is an issue that we're all trying to solve through hardware, and it's proving very difficult. But you can make cars, self-driving cars, and this also lends itself to drones and a lot of the things that drones are being used for. Or maybe you're interested in the hardware, okay? These are what we call neuromorphic chips. Or here, this is the CEO of NVIDIA working on this new bus architecture, which makes things super fast, which just got announced. If you like hardware stuff or nano hardware, AI chips modeled after the human brain and how it works, there's a lot of hardware possibilities. Down here, this is imaging and figuring out different stuff. This right here is specifically breast cancer and another kind of cancer imaging. Through the use of AI algorithms, essentially, we can predict whether someone has cancer or not better than a human now using a machine. So you have a higher chance of living because you get an earlier diagnosis. Or if you're interested in things like robots, whether this be the Boston Robotics, I don't know if you saw this video or not of the dogs that running through the forest, which is kind of scary, hunting people. Or this is an open source robot you can build free of charge. They have all the stuff listed there, all the software, everything. You just go build it. It's awesome. Or, and this is more controversial, love bots, if you will, which are robotic companions. This is unethical. Humans developing real relationships with robots. All of this kind of stuff here, when people say AI, this is generally what they're talking about. All these different areas. So the interesting thing is that, and this, I'm sorry if this is tough to read, you'll have to watch the video afterwards. This was pulled from a previous talk on some stuff. AI is very mathematically oriented right now. So it's based upon a lot of statistics and probabilities. And what that means is that you have all these different areas. You have three main areas. Things, unsupervised learning, which is basically moving data around and sorting it out and visualizing it. So if you're into that kind of stuff and you love charts and you love making sense of all this information and categorizing things, because a lot of people love that, then unsupervised learning is more of your kind of area, sorting all that information out, segmentation, recommendations, discovery of information. Now, if you like supervised learning, these are things like some of the listing identity fraud, customer relations, predicting the weather, predicting how long people are going to live. This is, we have data, and we know that this is approximately what should be. So, we're training the computer. This is kind of how the world is. Let's train you on how it should work. Okay, supervised. And this is reinforcement learning. This is like game AIs. Have you ever played a video game that got better as you played it? Like if you were okay, it would just stay okay. But if you were really good, it would up the difficulty level, right? That's AI. It figures out how good you are and plays you just hard enough to make it fun. Okay? And that's a lot of robots and learning tasks. There's a constant reinforcement. It's constantly learning. So, if you want to get into this, you're going to need to know math. A decent amount helps. Okay? If you really want to get into it, what you should do is when you go into high school, okay, you should focus, at least get through Calculus 1 and understand what something called a derivative is. Okay, if you've done physics or any kind of math, you'll get that. Basic high school math can get you really far. Okay, you can make a lot of money with that. Okay, so, but you got to focus on this stuff, Calculus 1 derivative theory. Okay, which means that if you're a freshman or you're getting started, you have to plan that track out a little bit. You have to say, okay, I'm going to do some math stuff. Honestly, I don't remember a single thing from calculus. I remember the concepts, but I don't remember how to take an integral. Okay. I know I shouldn't probably be saying that necessarily, but you got to understand the concepts and why things are the way they are, because then you can apply them later. And then there's this thing called linear algebra matrix. Normally you run into that in college, but if you're decent at math, like if you're good at calculus, you'll figure this out in a couple nights of study. It's not that hard, but these are two big things that help. And just understanding math, statistics and probabilities is helpful, and just how functions work and things like that. It helps. Okay? Now, I'm going to come back later and tell you why this isn't the only thing you need. But this is definitely a big one. So, be interested in math. Now, this is as much about life as it is about AI. If you want to get really good at something, or you got to pick a problem you want to solve for yourself. So, I know a lot of people who they'll start companies and they'll say, this is so awesome, we're going to make a ton of money. And more often than not, those companies aren't going to make it because they're not necessarily going in to solve a problem that they have. Some of the more successful problems that get solved, or successful companies, are based upon, for instance, I know someone who they were applying for a job, and they got turned down because someone else had their name, and this other person was a felon. And so when they applied for jobs, everybody thought that they were a criminal. But that's not me. That's not who I am. But it doesn't matter. That's what Google says. And so they figured out, well, I have this problem. I'm being misidentified. Maybe I should create a company that helps the people get identified and raise their stature, so that this person becomes lower in the search rankings, and I become higher. It's called brand reputation. And he built a pretty successful company. They're at a Series B level, which is many, many millions of dollars. That's an example of taking a problem that you have and doing something about it. Find something you like. What if, I don't know, you want to program a drone, or figure out how to make your ROS project work because you want to, I don't know, deliver sodas to your table or whatever without having to go chase it. That's a problem. So for me, and I'm just using this as an example, I do a lot of work with autism. I'm heavily involved. I have a son who's on the severe end of the autism spectrum, and he's going to require lifelong care with me. And so he's going to be living with us a long time. And so I was like, okay, well, how do I solve this problem that I'm going to have? And I'm like, okay, I got this X many years to live, and what can I do in those X amount of years to solve this problem? And so I narrowed it down to the two issues that I specifically had, which were wandering and daily living, like being able to live day to day. And it turns out that I'm not the only one with this problem. People who deal with Alzheimer's. So maybe you have a grandparent or a parent that has Alzheimer's. About 1 in 4 Americans are dealing with that kind of issue. Then they have this problem too. And I've been talking to those people, and they've been giving me ideas, and we've been working together to kind of solve the problem. Likewise, daily living, the people who are going to live with them their entire life. They have this issue, and they're like, oh, then they'll come to you and try to work with you and talk with you. It's about finding a problem that you need to solve for yourself, and it probably is going to turn out that somebody else might have that problem too. Okay. So first stop, once you get your math down, is get an internship if you can. That's kind of one of the big things that I always tell people. And I know that Charlie and the work that you guys are doing at Penn Manor has national recognition. I mean, people really know what you guys are doing because it's amazing work. And you probably don't, if you're a Penn Manor student, you probably don't understand how special it actually is. But it's almost a quasi-internship-like program that you're going through, okay? And so you got a leg up there, which is great. So let me tell you some of the things that I've had people contact me. How do I get an internship? How do I work with you in particular, or this company? Here's kind of what you look at. You look at, learn a language somewhat and put a project or two up on GitHub. You don't have to be great. You can go on online tutorial. I mean, honestly, in this day and age, if you can't find the information, you're just not looking. Like I'll go through where to get some of that. But learn a language somewhat and put a project or two on GitHub so that you can show people, hey, I could take this Python project. I just code something real quick, okay? People will walk you through it from beginning to end, just as long as you're familiar. So build something cool and show it off. If you have a robot, or if you have some kind of nanotech project, or anything else that you're working on, it doesn't have to be great, just something fun that you threw together. I know a guy who put together a Pokemon identifier, which sounds so silly, but it showed that he could program a cell phone how to recognize Pokemon, which was cool. Go to meetups and get to know people. These kind of events are important, or networking if you have other kind of events where people like this get together. Science fairs, I'm sure, are a big deal. Or other kinds of events where technology people generally gather. I'm sure that there's things going on all the time. And the interesting thing is that while those people may not have an internship available, they may know somebody who's looking. So it's always good to know. Talk to your parents if you're in high school still, because they might know some people who are looking for internships. And here's another thing I always found is start teaching it as soon as you can. So if you have a knowledge about someone's here and you're maybe right here, always put your hand down to try to reach down to help somebody else up, right? Because what's going to happen is you're going to have to know your material pretty good to help that person up. So if you know it, start teaching it, and you'll learn faster that way. It's key to learning quick, especially now when you have to stay ahead of the curve all the time. So let's look at these coding options. Don't get overwhelmed here, okay? You don't have to know everything, all right? So I'm just going to show you what some people out there are doing so you can kind of get an idea. So there's languages, right? You need to know these. So you need to know language. There's Python, R, C++, C, Java, JavaScript. These are just some of the languages that people are coding in. There's systems, Linux, Mac OS X, forget Windows, okay? I mean, Windows does have its place, but not in this arena, okay? I'm just saying. Frameworks, and these are all kinds of frameworks, TensorFlow, PyTorch, Scikit, OpenCV, CUDA from NVIDIA, Amazon Web Services. So there are a lot of different things and a lot of different ways you can go. So let me narrow this down for you. Focus on 3, essentially. 2, and we can talk about this. So Python. I'd highly recommend learning Python. And the reason I recommend it is because you can use it on the internet as a web developer, or you can use it in AI. And everybody's building Python stuff because it's just kind of, it's been around a long time. It's very stable, and it's kind of easy to learn. Like, it's not a difficult language. It's a great language to start picking up. Now, with this, and I put an addendum because I just talked to somebody about it today, JavaScript is not the end of the world if that's your language, all right? I thought this language would die many years ago, and it keeps sticking around. And it keeps sticking around, and people keep using it, and now TensorFlow is starting to use it too, so I'm sure it's going to stay around for another 10 years. But that's not a bad one either, JavaScript, but Python. System, hands down, Linux. If you're at at Penn Manor, you already are probably dealing with Linux on a fairly regular basis. It's easy, it's free, you can do all kinds of things with it. It's honestly, it's a fabulous way to work. Now, you can also use OS X for the Mac. This is one of the reasons I do a lot of digital media work. I've done film, 3D, like all kinds of things. I tend to like Mac a lot because it has Linux that I can use for all this stuff, but it also has all my other fun stuff. If I want to do graphic design, I want to deal with pictures, a lot, or I want to make movies and stuff. I have what we call a GUI, point and click stuff that I can use here. So either one of these are great. Frameworks. Well, this is where it gets a little complicated because there are a lot of frameworks. Right now, the top 2, if you're into what we call deep learning, which is really hot right now, which is deep learning is programming like these things to do object recognition. So if I had a camera in here, it could say, oh, there's this many people at the tables. That's a chair. It could also recognize all kinds of things from satellites in space and stuff. And so that's kind of deep learning. I'm not going to go into it too much, but that's kind of, when people think of AI, that's a lot of what they talk about. TensorFlow and PyTorch are the top 2. TensorFlow you hear a lot about because it's from Google, and Google has a lot of money to spend on marketing. So TensorFlow is a big one, and it's actually fairly good. I shouldn't say it's fairly good. It's fantastic. It really is. It's just I'm not a big fan of Google. But it is a great thing to learn, okay? PyTorch is another one. PyTorch is actually kind of supported by Facebook, and despite all the bad things about Facebook, the evil blue empire and everything, they have a wonderful tool in PyTorch. Okay, a lot of research is being done with PyTorch. So these 2 are great for deep learning. If you want to categorize things and you want to deal with a lot of data, Scikit is like your go-to. OpenCV if you're doing computer vision stuff, ROS or other things. OpenCV is a big one. CUDA, the GPU revolution is upon us. All these things are powered by really good video cards, right? And NVIDIA is kind of the king of the hill right now. So learning that is a great process as well. So that's just some of the stuff that you have there. Okay, so I'm going to mention this because I'm one of those people, I've had a lot of different careers in my life. And one of the things that is key, who was it? Darwin used to say, what's the term? The strongest survive or whatever. You know, social Darwinism, it's always the strongest that survive. That's actually not what he said. He said it's the ones most adaptable to change that survive, okay? Which means you constantly have to be learning new skills, okay? Especially if you're young right now, every couple of years, maybe every 5 years to 6 years, the technology is going to be so different, you got to relearn everything over and over again to stay current, okay? So you got to learning how to learn is an incredible skill to know. So these are some courses that I'm just going to put up here that I've gone through recently that have been very effective for me, and I have no doubt they would be helpful to everyone out here as well. So Udacity is a great resource. They have courses on everything. You want to know how to build a self-driving car? Go to Udacity. They'll take you through it. Oh, one more point about training. I just wanted to mention, I knew this guy once in college. During those years, I had really long hair. I could pull back into a ponytail, right? Like Charlie over here. And you know, I was playing guitar and in a band and, you know, doing that whole thing. And I met this guy who was the most talented guitarist I had ever seen in my life. I mean, he made Van Halen look like a chump. I mean, he was that good. He was amazing. And I asked him, you know, I was like, so what's the secret, man? How did you get so good? And he's like, well, when I was growing up, when everybody went out to go, you know, play on the streets, to, you know, go play hockey or go play sports or whatever, I was in my room, you know, playing guitar. You know, when all these people would go out and, you know, they would go to this party or that party, I was in my room playing my guitar. And, you know, that's what he dedicated his life to do because that's what he wanted to do. Now, I'm not saying that you guys have to be a social recluse to get good at something, but it helps to stay focused. You know, and some of these Udacity courses, and the reason I mention that is because sometimes it takes 3 months to go through it, you know, during the evening. You know, going a little bit at a time. You eat an elephant, right? One bite at a time. You don't do it all at once. One bite, a little bit, a little bit, a little bit, and before you know it, you pick your head up and you finish something. Well, that's what Udacity is like. And it's self-driving cars, drones, computer vision, to like really detailed stuff. Pi image search, that's the guy who did the Pokemon stuff. You can go onto his website right now and figure out how to identify Pokemon if that's your thing and you want to do that. He's got some incredible tools. Google has a crash course that they teach all their developers. It's right here. You can go to their website and get training straight from Google about what they teach their people. This is a lot of software. Fast AI, cutting edge artificial intelligence, cutting edge, and you probably need to know some Python. A little math wouldn't hurt. So this isn't what you would hit right away, but this is cutting edge and it's free and online and available to anybody. MIT has. Now this is I got it from a course, Artificial General Intelligence, where we're working on building basically Terminator robots, you know, without killing everyone. Okay, so we're trying to make them good robots, right? Well, bless you. So MIT is a great place to go. They open up everything to you for free. Now, if you're into hardware, okay, I've done a lot of courses in my time. And I got to say, if you're into hardware, this is by far, hands down, the best hardware course I've ever seen. It's called The Elements of Computing Systems. It's by Noam Nisan and Shimon Shakten. They're two guys from Hebrew University out in Israel. And they have an online course, and they have a book that goes along with it. And they show you, they train you how to take a computer from basically a little, what we call a NAND gate, you know, shooting your electricity into a little thing, all the way to building a game of Tetris. Like, how do you go from there all the way to Tetris? And it teaches you how a computer works, which may seem like boring, but it'll make you really good at everything else. And it was an amazing course, hands down, one of the best out there. So if you're into hardware, I would highly recommend that. Okay, so let's take a look at some scary things recently, because everybody was like, what's AI going to do? So this is, I think it's called deep fake. And there's been some fun ones that have gone out there. This is some of these are, well, they're using generative adversarial networks, which are, they're taking a computer and pitting it against a computer and letting them battle it out to try to trick each other. And it gets kind of crazy. But one of the things that they're able to do is to transform images and video. And I always want to show this wherever I go. I always show this because I want you to be aware of something that's happening and you may not even realize it, which is that essentially, I know that I'm going to play the video here in a second. You're going to see people. This is the original on the left, and this is on the right. We do a lot of fun with Nick Cage because he's just awesome, right? But you can see this is the original video, and this is the video with Nick Cage's face implanted onto that person. Okay? And this can happen a lot, and I'm going to show you how it's happening. It can happen in real time now, as of a little bit ago. Real time, you could have somebody, I could be here and I could puppet anybody next to me saying anything and doing anything. With 60 seconds of your voice, I can duplicate 100% all of your voice. So essentially, what that means is that anybody can create a video right now of anybody saying anything. And it's going to be coming out. I just want you to know, I always make people aware because politics is coming out. You have a lot of things you have to learn, and especially as you know, if you're younger. Actually, this is for all of us. I got to say, we're going to have to start figuring out how do we detect what is real and what is not, because you can't just fall for everything now. Because we can do anything. You can do anything. So I'm going to show a video, and you can see some of this in action here. Okay, I'm hoping it works. Let's see here.
You look great too. Guys, I'm gonna jump in here. How is this possible? I'm looking at two identical Nick Cages. Well, Seth, explain it. Just calm down. Why are you crying? I'm sorry.
Now they didn't use the voice thing on these, but this is Mr. Bean's face put on her. That's Nick Cage as the Joker. That's Willem Dafoe, if you know who that is, on Jim Carrey. That one's not quite as good, but it's pretty close. There's Nick Cage again. This is Nick Cage as Jean-Luc Picard. That's from a highly underrated Star Trek movie, Insurrection. Okay. So,
Rich, can we ask questions to make sure it's on camera too? So that's happening in real time?
it can now, yes. Yep. Yep. So you have to be aware of this and understand what's happening. I'm hoping that schools are going to start teaching some kind of critical thinking format to address this issue, because it's a major issue. So that's one. That's just one scary thing that's come out in the last year. Generative adversarial networks. Now you can imagine how that's being used. There's some other uses that are under the radar. Now, this is the other thing that kind of is disturbing to me. which is, this is China's social credit system, will rate how valuable you are as a human being. And depending on this system, you will have access to services or not. So basically what this means is that every citizen in China is going to get a number attached to them of how good a citizen they are. And it's determined by everybody else. So imagine if you're on Facebook or Snapchat or Instagram or whatever it is, and you know, you give your friends scores, and they give you scores. And if you mess up, they can drop your score. Okay? So if you're not being nice to them, they can drop your score. If they don't like you, they can drop your score. But instead of it just being, oh, I'm sad and upset, your parents go to prison. Or they get sent off to a camp somewhere. Or you just don't get access to the trains anymore. Okay? This is called a social credit system. And honestly, it's mind-boggling that a modern country can do this. But because of what's happening, this is one of the ways that AI can be misused, is by governments in some ways. Okay? Now, it's not quite like this in the United States. We have our own issues in the West. Okay? But the way it's manifesting in the East has more what you would traditionally call big brother conditions. And this isn't the only things. There's also, China is making a massive push in AI right now. And they're basically, if you remember the arms race, if you're old enough to remember that, it was this big deal between the Soviet Union at that time and the United States to build better weapons so that we didn't attack each other and blow each other up, right? And so we were going to do this arms race. You know, there's the space race. You know, who's going to be the first to the moon? Well, this is kind of like the AI race that's going on. And right now, it's the United States and China. And you can see that there's a difference in how kind of we're using it right now. China's using it very heavily to monitor its citizens and curtail the individual freedoms, while the United States is more or less not quite doing that, but trying to empower individuals in a lot of ways. Doesn't always quite work that way here in the West, but so politically, there's some things that you need to be aware of as what's happening with AI as well, because it does affect you, because a lot of the parts that are being made in China. So a lot of the GPUs and stuff like that, things that we have to be aware of moving forward. Okay, so that's just something I put out there as well. A couple of things to be mindful of. So let's talk about some of these other things you may have heard of. How about issues in AI? How about hacking? The Microsoft Tay chatbot. Do you remember? I don't know if you remember hearing about that, but there was this big chatbot that came out. Microsoft put it out and put it on Twitter or something and said, hey, why don't you guys tweet at this and we'll train the hack, it'll respond to you. Well, Twitter responded as Twitter does, with a lot of anger and hate. And before you know it, within 24 hours, Microsoft Tay was a racist, xenophobic, nasty chatbot. And it was totally destroyed by AI. Because people, you know, people like doing that kind of stuff for some reason. But that's the issue of hacking these systems. How do you get in? So not only do you need people who know how to get in, but you need people to defend that. So if you're interested in like really becoming a really good coder, you can figure out, how do we get AI to understand AI better? Biases. These are some things. How about the Facebook facial ID project? You might not remember this. But it was a big news because AI relies a lot on data. So whatever you feed into it is what it learns. So if we have biases outside of here that we feed into the system, that's what it learns. So the Facebook facial ID project, it misidentified African Americans as apes, which was a big deal because they did not put enough African Americans in the representative data set to determine properly what the human condition was. Now it's a big deal because that's Facebook. That's a big multi-billion-dollar company. Imagine what these other companies are doing who are on a shoestring budget. What are we feeding in here? Okay? Biases. It's interesting. I mentioned that as well because it's interesting that the Chinese are starting to use AI for their legal system to determine whether you're guilty or innocent. I can imagine what biases are going to go in there. Legalities. Who pays for dead pedestrians when the self-driving cars hit them? Just happened in Arizona. Who pays for that? Is it the person who's in the car driving, who owns the vehicle? or is it the company who made the AI? You know, so if you wanted to be a lawyer, you could figure this out. If you wanted to deal in sociology, you could deal with this. Like, you can contribute to AI and not have to be a math person. There's a lot of issues that need to be represented. So you can contribute. You don't have to be a math person to help solve a lot of these challenges. So that's why I put these up here as kind of a last follow-up, is that you don't necessarily, it's a lot of writing. I know you're probably not going to read it all. But you don't have to be a math wizard to contribute and solve these issues. Especially for you, those of you in high school still, these are issues you're going to be dealing with when you go to college and in your 20s, like a lot of these. So a lot of people who are dealing with AI now have gone through and done this stuff. So a lot of reading, okay? And I'm not talking about Wikipedia, okay? Wikipedia is easily manipulated. Think about thinking. Think about problems. Read philosophy. There's a reason that the first thing you could study in college a long time ago was philosophy. They didn't care about all these other things because philosophy, thinking about things is important. Understanding what is a self, what is a person, what makes a person a person. It's a real question we're dealing with in AI. And you know, you have people like Carl Jung, Hermann Hesse, Nietzsche, Rand, Toni Morrison, Anne Rice, Heidegger, Hume, Descartes, Asimov, Buddha, Lao, Christ. All these people thinking about what makes a self, what makes a person, how do we live ethically. I also put watch good sci-fi in here. And this is just fun because, you know, watch Black Mirror. They've really done a lot of stuff. That social credit system was on a Dark Mirror episode. I don't know, maybe the Chinese watched it and said, hey, that's a good idea. Maybe. They've also had some other ones. Bicentennial Man is a great one based on Isaac Asimov. Mr. Robot, if you want to learn about kind of what hacking is like, it's actually semi-accurate. It's not great, but I mean, it's pretty good. It's on Amazon, streaming on Amazon. Come on, Trek, of course. You know, it's kind of a basic one. But there's tons of good sci-fi. I'm not going to go into all of it. But learning good sci-fi, watching good sci-fi, because a lot of people have been thinking about these problems for many years. And it'll help you kind of get that. And I always put this, no essential dystopian lit. And what I mean by dystopian literature is these are books that where people say everything is screwed up, you know, and it talks about how things can go bad. And you know, these are some famous ones. A lot of us grew up, you know, during the Cold War, or we grew up during the War on Terror, or you know, this war, that war. Who knows what war's next? But it talks about, you know, Brave New World, 1984, Fahrenheit 451, which is coming out on HBO. I doubt they're going to make it good, but Fahrenheit 451, Animal Farm. You also got to know some of the sources, like the Milgram experiment, you know, which I'll tell you so you don't fall prey to it. The Milgram experiment was essentially done in the 1960s by a man out in California. And you would come in, and you would be sat down, and they would get you to push a buzzer, and this person in another room would scream because you would be shocking them, all right? And technically, you wouldn't actually be shocking them. The person in there was acting. But every time you push the button, they would make it seem like that person was getting louder and louder until they said, this will probably kill the person, but you need to keep pushing the button. And they wanted to see who would push the button. And it was an experiment done because Milgram's family was in the Holocaust. And he wanted to understand, how could these Germans, who are normally good people, how could they be turned to evil in this way and do this? And so he created the Milgram experiment. You know what he found? Over 60% of the people, normal everyday people, would do what they're told by a scientist. And it's been replicated all around the world. It's because we have it's a question about how people deal with authority and those kind of things. But that's, you know, in the structure of scientific revolutions, which is about how science can be manipulated one way or another and how it's handled. You know, because we deal with these things in AI a lot. Like, you know, these are questions we're really focusing on right now, like ethics of AI. You wouldn't begin, I mean, especially with all the stuff I showed you earlier, we're just at the beginning of this. And knowing this stuff, it's, when you go to talk to AI people, I guarantee you almost all of them know this. They've all read it. Maybe not all of this, but a lot of it. but they understand about where things go wrong and the challenges. And it's good to know them. Okay. All right, so what's next? And on that note, let's go do this thing with AI. Go have some awesome fun. So that's about it for that. I hope that was a great introduction to AI, all the things you would need to learn. So we covered that, all the things that you would need to know, all the different areas, some things that are happening right now, some things to look out for, and maybe just some things to keep in the back of your mind as you become a lifelong student of building awesome stuff. Cool? All right. So that's about it. I guess I'll start taking some questions from people. So thank you. Cool. All right, so who has questions? Anybody? Anybody have questions?
Okay, so unconventional careers for AI.
Yep.
You mentioned a lawyer.
Yeah.
What was that, social sciences? Or?
Yeah, social sciences. Yeah.
What about psychology? That's one thing I was curious about. How do you figure out psychology, and then once you get beyond I mentioned the technological singularity.
Yeah.
Once you deal with machines that are basically upgrading themselves,
Sure.
is there any way to fathom that psychology? We could barely understand the human mind, so
Yeah.
is there any chance of when you talk about predicting, where it's going to go?
Sure.
The movie Her, right?
Yeah.
They basically, I don't want to give too many spoilers away, but they basically implied that, the machines will start talking to each other, and they'll, okay, this human thing is getting kind of boring, and they're just, light years beyond us. So.
Yeah, so, okay, so there's a couple questions in there. So let's break that down. Let's first start off with psychology. Absolutely. Absolutely. In fact, that's one of the things I studied. I studied philosophy and something called scientific and philosophical studies of the mind, which is a combination of psychology and philosophy. But we looked at neuroscience, we looked at how the body worked, we looked at how mind, this idea of mind and what it is. Psychology is great. And you would want to probably be focused, there's a lot of the work in building robots is focused on something called constructivism, which is this idea that when you're a baby, when you first get started as a baby, you learn I first learned peekaboo. Like, you ever play peekaboo? It's this level where you understand that people don't disappear when they put their hands in front of their face. You got to learn that because you don't know that as a baby. You got to learn that. That's what peekaboo trains you to do. And that's called occlusion, understanding that things are behind there. And so once you learn that, then you can learn about hide and seek and all these other things and abstract ideas, and you can start building. And so it's this idea that you construct a human being over time. It's the child developmental psych. And that's also an idea of how we're looking at building robotic systems. So we're looking at building very simple hardware sensing ideas. Can we pick this up? Can we grab that and feed it in? And then from there, can we create this level of abstraction? And then this, and then this. It's straight from psychology.
So evolutionary psychology would be helpful because
Sure.
then you figure out why our brains do those?
Sure, absolutely, absolutely. I mean, it's a great thing to know a lot about, and you can definitely. And psychology, they also do some coding sometimes, especially in statistics. You're going to do a lot of statistical stuff. You might even work with a language called R if you do a lot of psychology. Now, you also talked about legal and stuff like that. Yes, lawyers are going to need to know cyber. It's going to be an offshoot probably of cyber law would be my guess. But yeah, I mean, when you go to law school, though, you don't focus on a particular aspect of law. You learn it all, and then afterwards you go on and learn your specialty. But law would be going.
I'm sorry.
Yeah.
On the West Coast, they have a lot of futurist conventions.
Yeah, sure.
Do they have colleges just for futurism? I'm pretty sure there's at least.
Well, I bet you Stanford would say that that's who they are, but who knows?
But I'm just saying there's so many dimensions. I'm just wondering you could probably have a whole college just make all these different angles.
Yeah, I mean, mostly that's. I would say that that's what post-grad work is for. You definitely want to get a certain level of critical thinking when you're an undergrad, and then when you want to really delve into stuff, you go into post-grad for those kind of things. Would be my guess. Nothing like that has developed. I mean, you have a lot of these places like Fast AI who are trying to build these communities focused on a particular subset, but nothing no big organization. I don't think we're going to find ever a centralized source. It's going to stay decentralized for a while. But just my guess. I don't know. Just a guess.
Is it because there's too much divergent thinking?
No, I just think it's just because it's more efficient for resources to do that. Like it's becoming more difficult to centralize those resources for something like that. Just a guess. I don't know. So, yeah.
Well, kind of going off what he asked about psychology, what about neuroscience? How well, like, sort of from what I understand about AI is that you essentially have computer networks that mimic human neurons, and that's how computers are able to learn things at a deeper level. So I'm just wondering how much would you have to know of neuroscience to understand how artificial intelligence works, period.
So now you're in my wheelhouse here, all right? That's a good question. So I studied a bit of neuroscience growing up. I'm not an MD by any stretch of the imagination, but I did study a lot and I've followed it over the years. So AI takes off of neuroscience. It's kind of like it's like a movie based on something. You know, it's not really the truth, but you know, it's close enough that you get the general idea. And that's kind of where AI is right now for the most part. Now, we're taking the idea of a neural network, which is how your brain works, and we're going to make a computer silicon version of it. Okay, it's not exact. However, there has been hardware made that mimics neurons exactly, and that's where I'm talking about the neuromorphic chips. And you know, IBM and some other people are building them. But here's the problem with the hardware: is that they can't write programs for it, like because they just don't understand how it works. Like they can create these chips that look like a neuron, but how it actually interacts and works together isn't precise yet. So we need to find out new ways of building assemblers and compilers to process programs for that information. And it's a great field to be in if you're into that kind of stuff.
Yeah, I'd imagine there might be some challenges considering neuroscience is kind of a relatively new science. It's not quite as advanced as the other sciences.
Sure. I mean, we're still learning new things about the brain all the time and what different parts of the brain do. So, but there is some, I'm really interested in that because ultimately I think that we're going to have to redesign some of these systems. I'm interested to see, I've been following a couple of different things. Right now, computers have these, it's based on something called von Neumann, which is this guy back in the 30s and or 40s maybe. He designed this architecture about how things get calculated and you know how memory works in a CPU. And it really hasn't changed that much. It's just that we've been able to pack a lot more transistors in. We've moved things around a little bit with caches and stuff. But basically, computers have been the same now for 40, 50 years. You know, it's just, you know, they're essentially the same, this idea. But there's other kinds of computers that they're starting to play around with, quantum computers, which are able to do amazing calculations, very specific kinds. There's these things called mem resistors and mem computers, which are able to carry information and process it at the same time that they're trying to build, which is more how your brain works, actually. So you know, there's a lot of different kind of computing paradigms that still are options. So if you're interested in hardware and mimicking the brain and doing those kind of things, maybe you'll be the next you know, great person to build a robot in your garage, you know, just on some ideas. It's a great thing. I love neuroscience and AI.
I was wondering, like, with China, let's say, I guess what they're pushing for now is some sort of treaty to kind of like put down ground rules, like, okay, we're on the verge of something.
Yeah.
I'm just like, okay, are these people? I mean, we got Trump up there. Is anybody reasonable enough to be like, okay, let's make a treaty, technological singularity, it happens. What then? Because it's like, I feel like the public is way behind the curve, obviously.
Way behind.
And so, how close we are, people keep pushing back that it'll be 20 years, it'll be 30 years. I feel like it might be much closer than most people think because they already have, they already have AI that can improve with you. So, in a very, I guess, a linear way.
Yeah.
But I'm just
Well, I don't know too much about the actual treaty itself, but I wouldn't believe a single thing that comes out of these people's mouths. I really wouldn't. And the reason I say that is because a lot of these same companies are the same companies that are help building all this crap in China because they're making money off of it. I think the only company that's really had any cojones to actually stand up to those kind of issues that we, those kind of issues that we appreciate here in the West is Google when they pulled out of, and basically pulled out of the Chinese market and said, we're not handing over people's data. That's not who we are. The Chinese, in case you didn't know, the Chinese, when you go into their market, have a technology transfer as one of their main things. So if you go over to do business, they say, you give us all your technology when you come over, and then you find out 3 years later that you have all these competitors because the Chinese have given them to the competitors. It's a major issue. They're basically just IP theft. But these companies like Microsoft, have been known to work with those companies. Some of the bigger ones, I think the OpenAI project has the potential if we keep things open source. The open source community is really a good defense against those things, but it's really challenging to stay funded.
What is the open source? Is that, I did want to ask, like, what type of personalities are involved in artificial intelligence? Just very smart people in general, or does it pull in a certain type of person?
I don't
think they've done psychological profiles.
No. I mean, I think anybody can be involved in AI who's interested. Like I mentioned, there's all these different industries and fields that you can be focused in to help, work in the AI field. It's not just computers. But to actually produce the computers and stuff like that, you gotta have to be a math-oriented person. You have to be a logical kind of thinker, and you have to go through it that way. Yeah.
Okay. Really quick. So if somebody is just like, I'm a psychiatrist. I have my degree. I've gone through the whole program, but something's pulling me into AI.
Sure.
Should they just present themselves, and some company will be like, well, we can find a use for you, or what's the best way to go about it if you're
Oh, yes. Okay. So in those cases, what you would do is find it, like I mentioned before, find an issue that you could help solve a problem for and try to start solving that problem. So if you're a psychiatrist and, is talking about, so some kind of diagnosis for like a mental disability of some kind. You could, maybe you, just call up, go to a meetup and just talk to a couple of people and say, hey, I'm trying to assemble this data. Could somebody here help me, assemble the data? And you could, people like to help. When you go out to those kind of things, a lot of people like to help. And, maybe they could help you start assembling data. And then you could, present something at a conference or something like that. And then, from there, things kind of grow. I always recommend people try to solve a problem is the easiest way to get in. Any other questions? Yeah? What's up, Charlie?
So Rich, can you talk a little bit about, you're doing some AI work here in
Yeah.
Lancaster. What else is happening in the Lancaster scene with AI?
Well, it's kind of light here in Lancaster right now. So that's one of the reasons that we're putting this together. We started the Lancaster AI meetup in January because we wanted people to start learning AI in this area. There's some very strong companies in particular industries that are going to be revolutionized by AI here. We have some great embedded electronics people in Lancaster. We have some great SaaS coders, here. And, AI is something that I think we could definitely grow here. I haven't announced it yet, but there is a very good chance that later this summer, I'm going to start direct training courses in conjunction with some other OpenAI folks to offer training on the weekends to people for free. To come out, you want to learn TensorFlow? I think we might be using PyTorch, but just come out for like 6 weekends or 8 weekends, and it's a commitment. It's like, a day out there, but, get that training. And it's going to be a lot of investing in people up front, I think, locally. Now, if you have those things, you can always go to a big city, afterwards. Lancaster's a great spot. I haven't always lived here, but Lancaster's a great spot because we're 2.5 hours to New York, we're an hour to Philly, 3 hours to DC. I mean, right there are 3 major markets. And the cost of living here is really low, so comparatively. So you can actually get to a lot of those places. If you learn AI in this area, you have a lot of options. There's I probably shouldn't mention where he's from, but there's a recent valedictorian who's at Stanford right now who's coming back to work on AI stuff because he's coming back to work in the area. And that's kind of how it's going to happen, I think, here, is slowly just a few people being interested in doing cool stuff.
Is the main motive to get it to grow Lancaster, the kind of the location? Is that the main issue? Or?
Well, I mean, I think part of it is just wanting to make Lancaster a better place for the technology community, because everyone benefits. I think they really do. I mean, it'll help. A lot of the high schools, I think, will be able to offer extra options to their students, opportunities they have at other places. Is a great thing. For companies here, companies will come down here because if you have decent AI talent, they'll bring it down, which is great. More jobs for everybody. So I think that it's a win-win for everybody by growing AI in the area. And plus, it's the home of the Kentucky Rifle, so or Pennsylvania Rifle, yeah. So we have a great history of building awesome stuff here in Lancaster.
And the contrast with the Amish is perfect.
Yeah, exactly. Don't let them fool you. I used to work on their computers in their barns,
There's a part of the movie where the guy playing dumb, he knows all about the car.
Oh yeah, that was Kingpin, I think.
Not Kingpin, it was another one.
No, but I remember what you were talking about. It was a good one. Other questions?
Oh, can I get one more in, please? So what do you think, no spoilers, but Westworld, I mean, is that like a...
Okay, that's a good one because that's more along the lines of building lifelike robots. Kurzweil believes we're about, and now it's more the artificial general intelligence. Kurzweil believes we're about 12 years out. So he's predicting around 2030 we'll have something along those lines.
Is that connected to the singularity, or...?
Well, he thinks it's along that path. But I think we're a little bit further off than that because we don't have the materials for Westworld to replicate a lot of the the muscles and understanding how we would actually, what kind of software could you get to send signals properly? I mean, you really need to understand wetware, which is this idea of how does the body work as a cybernetic. So I don't think Westworld is really that close. But I will mention, I talked about this earlier, Y Combinator just had an event. If you don't know Y Combinator, they're like the Harvard of startup incubators. So a lot of great companies go through Y Combinator. They're out of Silicon Valley. And they invest a little bit of money in companies. And they just recently had a company come through there that is able to take the mind of a rabbit and save it in a computer. And they've successfully done it. And there's only one catch. It kills the rabbit. So, they're working their way up to primates. And then they're going to start, who knows what else happens. But the deal is, you could do it, but you're guaranteed to die. Because essentially they freeze your brain in a particular way, and then they're able to download it based upon the way the network is at that very second in time, and then save it to the computer. So that stuff that Kurzweil is talking about, the singularity and transferring your mind to a computer and the technology kind of, running with it, it's a possibility.
Beyond external world skepticism, how can you be sure that that's the same entity, the same soul or same person? Like the rabbit, I mean,
you can do it from testing and stuff. I mean, B.F. Skinner used to do a famous thing, that had a famous saying about behaviorism. The question is not whether machines think, but whether men do. And so this is, an issue where a lot of philosophers and other people and great sci-fi has asked this question: is this going to be the same person? So that's something to think about. But with that, I'm going to close it up. So thank you, everybody. Thanks for the great questions. If you have any more, feel free to reach out to me. We're going to do this again, and maybe what we're going to do is we're going to change the location. So normally we've done it at PubForge. I'm working to have it at the Candy Factory, which is a co-working space where there's a bunch of startups there. It's kind of a hot scene for the startups in Lancaster. So you know, hopefully we can get that. It's easy to get to for people, and it's a nice location. So see what we work out, and maybe we can do something else. Maybe come out to you guys out at Penn Manor, and maybe do some fun stuff there too. So thank you, Charlie, for helping us get out here, and have a good day.